let's talk about projectile motion. So it is a two-dimensional motion in which an object travels in both the x-axis and the y-axis. So in this, the path is like that. We throw the object with an angle theta with the horizontal, and it goes like that, and ultimately comes to rest. So in this, it attains a maximum height and a horizontal range and takes a time t. So we have to calculate today what is the expression for this h, r and t in terms of u, g and this theta. So for tackling this type of motion, we have to consider two directions separately. So first we say in the x direction, and in the y direction. So in the x direction, you can see that we have thrown the object with velocity u at an angle theta. So in the x direction, the ux is u cos theta, the horizontal component. Similarly, in the y direction, it is u sin theta, which is the vertical component. So we have talked about speed. Then we talk about the acceleration. So you can see that acceleration in x direction is 0 because all the acceleration is in y direction, which is minus of the acceleration due to gravity. So first we have to find the time period. So we can use the y-axis in this because we know that the displacement in y direction is 0. The object starts from y equal to 0 and also ends at y equal to 0. So we can use kinematics to derive the expression of time period. Let's see how we can do that. So first we write that initial velocity in y direction is u sine theta. Acceleration in y direction is minus g, and let's say it takes time t, and we know that sy is equal to 0. So we just use sy is equal to ui into t plus half a into t squared. So we have 0 is equal to initial velocity in y direction. This is u sine theta into t plus half into the acceleration minus g into t squared. So this is going like that, u sine theta t, u sine theta t, and this will go there and become positive, is equal to g t squared by 2. T will cancel 1 t and we get the expression for t, that t is equal to 2 into u sine theta upon g. So we have got our first expression for the time. The time it will take to travel its journey is t is equal to 2u sine theta upon g. You should learn that for solving the problems. Then we move ahead for the h max, the height max for the object. The height max is like that. The object shows a parts like that. So at this point it is at the h max. So we have to find what is the expression for this h max. So we will now use t is equal to 2u sine theta, also 2u sine theta by g, also to derive this expression. So at h where the object is at h, you can see that the uy is u sine theta, okay, but the velocity final at h is 0 because the object is now trying to go down. So at this particular point its velocity is 0, and we know that acceleration in y direction is minus g. So we have to find the h max. So let's now again apply the equations of kinematics. So we have ui, ay, and we have also derived the equation for time being also, and we have the vy also. So we should use s is equal to v square minus u square upon 2a. This is similar to v square minus u square is equal to 2as. So s is equal to v square minus u square upon 2a. From here we can find the expression of for s, which is the h here. So the final velocity is the final velocity is 0 minus u square sine square theta upon 2 into what, minus g, which is the acceleration here. So we can get h is equal to minus minus will get cancelled. H is equal to u square sine square theta upon 2g. So this is the expression for the height max which the particle will cover in its path. So we now have the some expressions for the motion of this particle. So we have time is equal to 2u sine theta upon g, and we have h max is equal to u square sine square theta upon 2g. So now we have to find the horizontal range. So for finding the horizontal range, we have to consider the x direction because the horizontal range is the displacement is in x direction. The particle is covering this much horizontal distance in its journey. So we have to now consider the acceleration in x, initial velocity in x, and the final velocity also in x. So we now have time with us. We have time, we have initial velocity in x direction also, and we have acceleration in x direction also, which is 0. Acceleration in x direction is 0. So we will use s is equal to ut plus half into at square, which x into x direction, u also in x direction, and a also in x direction. So there is a good thing that the a is 0, so this term will be cancelled, so our calculation will be very easy. So the acceleration in x direction is 0, so we have Sx is equal to ux into t, and it is very simple that ux we have is u cos theta, and time we have derived that t is 2u sine theta by g. So we get u cos theta into u sine theta, so u square cos theta sine theta into 2 upon g, and we know that the cos theta sine theta and 2 become, this whole thing becomes u square sine 2 theta. So we have r is equal to u square sine 2 theta by g. So today we have derived all the expressions for r, h and t for the projectile motion. So let me write all the equations here with another color. So we have derived that h is equal to u square sine square theta upon 2g, and we have time is equal to 2u sine theta upon g, and we also have derived r is equal to u square sine 2 theta by g. So I hope you enjoyed the video. Thanks for watching. We will meet again with another interesting concept.